Hi Merlin, it's Anastasios Arima from IperionX here again. I'm the co-founder and CEO. At IperionX, we're looking at developing a sustainable supply chain of titanium metal back here in North America to supply the North American, European and global markets.
Taso, good to be speaking to you once again. We last spoke in October, and we covered the PEA that you put out last year. But here we are at the start of 2023. You've had some bumper news releases already this year. What I'd like to do today is to cover the highlights of last year, cover the news releases that have come out in January, what it means for the company, and then talk about the other plans for 2023. So could you first start by giving me a quick summary of the kind of the highlights and the key elements of last year for the company?
Yeah, last year was a great year for us, even though the backdrop of the market was quite volatile with the way inflation ended up over the last 6 months of the year. But we still were able to achieve a lot. As you said, we completed our preliminary economic assessment, our scoping study on our Titan project, which is an important strategic asset for us. It is the largest titanium mineral resource in North America. And we started looking at the permitting of that asset, and also ahead of the pre-feasibility study, looked at completing the feasibility level metallurgical test work on the Titan project. But I think more importantly, we advanced what we see as immense value in our titanium metals side of our business. Last year, we took over operations of the titanium metal industrial pilot facility, we're calling it, in Salt Lake City, Utah, which was built by Dr. Zach Fong and funded originally by the Department of Energy, the ARPA program within the Department of Energy. We took over operations of that in last year, at the start of last year, and we spent quite a bit of capital on that, taking it from what was a research and development facility to sort of semi or industrialized facility. Brought in a great team, added some significant capital upgrades there, and really progressed the development of our titanium metal powders. So day in, day out today, we produce titanium metal powders. And last year we started securing our first customers that really validated the project or the technology. Our first major customer was Panerai out of the Richemont group within Switzerland for luxury watch applications, where the luxury goods sector is looking at sustainable sources of supply. And then we've continued to work with other OEMs across industries, and of course the military as well, given the backdrop of the geopolitical tensions with Russia and China, and the fact that titanium is controlled by those two countries. 70% of control is from China and Russia. There's a lot of focus from Department of Defense, national security angles for us developing our titanium metal capabilities here in the United States. So we had a great year in really proving it out.
And I mean, here we are in early February, and I mean, if we take January as well, you've got you're working with the Army and the Navy now. So if you kind of include that into kind of last year's work to bring us up to date, so let's go straight into those two announcements. What are they and what do they mean?
Absolutely. So look, we then started off 2023 with a bang. So we were working and we were known by the Department of Defense during last year. Early this year, as soon as we came back from New Year's, we won an Air Force Grand Challenge, essentially the ability to recycle the titanium metal and metal scrap for the Air Force in their 3D printing applications that we're using today, which will eventually lead into a lot of other Air Force recycling programs. We expect it to lead into a lot of other titanium recycling programs within the Air Force. The Air Force is a major user of titanium metal in current fighter jets like the F-35 and future weapon systems as well. So that was a huge win.
Hang on.
And then
just on that, you talk about this kind of Air Force Grand Challenge. Was this a national competition? How long did it take for the deliberation? I mean, was this something that you applied for in the middle of last year or the beginning of last year? What was the kind of the time frame, and how many competitors did you have? And what's a little bit more color, please?
Yeah, so it's a good question actually. So the Air Force Research Laboratories was, as they've been using more additive manufacturing, they've been looking at reducing the cost of the raw material supply chain in additive manufacturing, which is one of the largest costs of 3D printing or additive manufacturing. And in addition to that, they've been looking at how do they recycle these new types of products they're making from additive manufacturing in titanium metal. And so middle of last year, they put out this grand challenge. We had never really interacted a lot with the Air Force. We had interacted a lot with Navy and Army before then. So I won't go into details because I think it's not public exactly who we competed against and how many there were in there, but it was nationwide and it was open to all titanium producers.
Are there other additive manufacturing 3D printers companies out there with the ability to print 3D titanium?
So to print, yes, absolutely. To make the titanium metal powders or the feedstock or the raw material, there's only a few. The big ones are quite well known, like GE Additive had bought APNC, which is one of the top suppliers today. And there's a few other very well-known companies in the supply chain for making these raw materials. We won the challenge because we're completely different. The way we produce our titanium metal is not through the traditional process, which is what everyone else relies on. So we're much more sustainable. We use 100% scrap today. So we are the only company that is out there really using 100% scrap from today. So no virgin material supply. That will change in the future, but today we are doing 100% recycled product. So we came into the competition and it was good companies that we went against, but I'm proud that we won. And I think
what are your differences? So is it just melting point? Is it just a temperature input?
No. So it goes back to the technology. So our technology is a complete change to the titanium metal supply chain. So we don't go through any melting. We don't go through the traditional crawl process. So today, the titanium metal is manufactured through the crawl process, and then you take titanium metal sponge, which 70+% is controlled by China and Russia, and then you melt it into ingots, and then from ingots you have to make it into products. Now, to make one of the more common raw materials in additive manufacturing is powder, spherical powder. To make spherical powder, you have to take titanium metal ingots, you have to make them into wire. Wire is very expensive. That is then taken into a plasma or gas atomization process and melted into spherical powders. Sounds really expensive? It is really expensive. Sounds very energy intensive? It is very energy intensive. And our process completely gets away from coal. So we actually just take scrap, we put it through our process, and we come out naturally with powder. In the process as well, we sphericize it, not using any melting or anything, and just deoxygenate it and come out with powder. So because of that patented process, it completely upends the supply chain. So we've talked about being plus 50% cheaper than the current supply chain. I think we're going to be a lot cheaper than that as we scale. And we have equivalent properties, and we are far more sustainable. So we can take our 100% recycled product, 100% scrap, and make that into 100% recycled product. And we use no carbon in our process. So we're zero Scope 1, Scope 2 carbon emissions.
And so you don't go through the multi-stage process. You just take the scrap in, and out at the other end of the black box, out of your magic black box, comes the pretty much.
And that's where the Air Force Research Labs comes in and has a big look and goes, same as with Panerai, and says, does this black box work? We've talked about the technology a lot. Essentially, it's based around a refining process which is different, which was not known before, based on a scientific breakthrough Dr. Zach Fong had in 2016, where you can actually refine titanium in the presence of hydrogen, which people didn't know before. So it's sort of like, as we scale up, I always say at some point Dr. Fong's probably going to get a Nobel Prize or something in 10, 20 years' time for this, because this really does change the way we think about how we can make titanium metal products. You don't have to have coal or ingot anymore, and that's what it's based on.
When you submitted to the Air Force Grand Challenge, Air Force Research Grand Challenge, did they come and visit? Do they come and spend time on the plant? And how long does it take them to make their mind up and say, actually, this is what we want to, invest in and support and pursue?
So they did not do a site visit, I can say that, but it is quite a technical review. So it is very much material scientists and PhDs that review and go over what we're doing. So the challenge has a few aspects to it. There is an aspect of will be visiting site. We've already made the powder. So they gave us 10 months to make the powder. I mean, recycling of titanium metal powders was really challenged before we had developed our process. So I don't think the Air Force Research Labs really understood that we're already doing it. So they came out with the challenge and said, whoever wins has 10 months to make the powder, and that's all we do is recycle titanium metal powder. So we've already made it, right? So they will come, they will see the process and all that, but they're very interested in as the Air Force moves to new weapons generation systems, looks at also repairs and maintenance as well. So say you have a part that's broken, instead of waiting 6 months for it to come from overseas, you can just immediately print it with we can actually take that broken part and we can print it within a few weeks, recycle and print it.
So is the crossover between the kind of the research lab and the an actual a part replacement, does that exist? I mean, can you do that, or is it going to are you going to have to go through a complex bureaucracy of research lab and then getting it proved and supported and
you will always have to go through a bureaucracy, whether it's there is a strategic need today because of the way the market is with government and DoD-driven processes. Of course, you're going to have to go through that, but they have already chosen that they want to go through additive manufacturing, at least for repairs, maintenance. When you get into new weapons programs, definitely you want a few years ahead of, say, new weapons programs to be working. So that naturally comes, but repairs and maintenance can be implemented relatively quickly, and that's very similar for the Navy contract we just or the Navy, not contract, the Navy collaboration we just announced as well.
So review that one for me, please. Can you summarize that arrangement?
So very, very similar to Air Force Research Labs, where there's a want to recycle titanium metal products and parts. The US Navy has this problem as well. Actually, the whole world has a problem with titanium metal today. Because of the intersection with Russia and China. So the US Navy has a very big problem around cast parts. So these traditional big cast parts, whether it's pumps, pump impellers that are used in every surface ship because of corrosion resistance and strength, these casting houses don't exist in the United States anymore. The big ones. The casting houses that are left in the world is China, Russia, UK and Norway, and even those are under pressure from the Chinese and Russian casting houses. So you have to have pumps on a Navy ship, whether it's for the nuclear reactors in a aircraft carrier, to pump systems for your fire systems, water, for your fire systems if there's a fire on board. They're all titanium because they need to last 30 years. And so the US Navy has an issue that these cast parts, not only do they take a long time to produce, it's if you have an issue, so say if a warship is coming into dry dock, is being repaired, and they find that this pump is worn out in 20 years instead of 30, they need to replace that pump. They go out to market and they find that it's a 12-month lead time for that specific pump component. So we can take that specific pump component. So Carver Pumps is one of the major suppliers of pumps to the US Navy. We can take that component, which is just a worn-out titanium metal component, throw it in our process, recycle it, make it into powder, and immediately print it. Cut that lead time down from 12 months to maybe 6 to 8 weeks. That is really what the Navy has got a big focus on that because these cast pumps are big. These cast parts are big, and there's a big issue, especially today when the US Navy is going through a big revitalization program to counter China, essentially, in its shipbuilding. And the Navy has, down the road from where we're building our scaled-up production facility in Virginia, they have got a large additive manufacturing training center that they just pumped a lot of money into, and so they're very focused on this. So I was able to meet with Rear Admiral Jason Lloyd, who's a big proponent of this. He's the chief engineer for NAVSEA, which essentially qualifies all these parts, and there's a big want to definitely drive these things forward. So it's really important.
Right. The immediate thought is that you use the word big, but I should imagine that a pump impeller for an aircraft carrier is not a bench scale piece of kit. It's probably a large bit of kit or a large part of large dimensions. You're in the process of upscaling your pilot plant. You've got the plan. I think that's one of your key plans for this year, $20 million. You've got some funding from the Virginia government, etc. Can you create a pump impeller on the pilot plant, or is it going to have to wait until you've actually created the bigger one because of just the sheer scale of the size of the kit, the size of the part?
Okay, yeah, no, it's a good question. So there's over 500 parts that have been identified by the Navy, which are replacement components that they want to replace. They range from anything from, I'm not going to actually say the weights because that's, but they're from small to large parts. Some of these pumps are as big as a car, right? So, there's some very big parts, but there's also some smaller parts, which we have the capacity to prototype today. So it doesn't have to wait for the scaled up facility. We can prototype and we can start qualifying some of the components now. But definitely once we are fully operational at the end of this year, we can be doing a lot more as well.
So there's a scale range between small and big, and right now you can do some of the small stuff, and by the end of the year you can do more, and then the largest bit is going to have to wait. But in terms of the, what do these contracts mean for the company? Because if you look at the valuation of the company, it hasn't really, you've stabilized in this kind of price range, 80 cents to $1.10 for a year and a half, 2 years.
Yeah. We just came out with the Navy last week and the Air Force Research Labs earlier. So as we get into this year, we'll be finishing off the Air Force Research Labs and making some more announcements to market around volumes and what that means for our company. And the same thing for the Navy as well. The Department of Defense is a very large consumer of titanium metal. So it is good to already be in with these programs and be developing these relationships. I think one really important thing as well is that the US government is very focused on these raw material supply chains and reshoring them in America. So they've thrown a lot of money behind a few of the bills, a few legislation that was passed last year, which will hopefully benefit us. So I think it's very positive on two fronts. On one, on securing future large contract orders, which is great, but two, on securing government financing for the continued development scale up of our company. And that includes not just the titanium metal part of the business, but also they realize that eventually you want the minerals coming out of the ground as well. So, there's a range of programs that are out there. Us having strong relationships in the Department of Defense really helps. In addition to that, there's a focus on not just reshoring these supply chains, but on green manufacturing, on sustainable manufacturing methods. And so we straddle both. We are reshoring a critical raw material supply chain in North America, but we're also doing it more sustainably. So 100% recycled, so fully circular, and also with low carbon, zero scope 1, scope 2 carbon emissions. So we're sort of covering off on the two big focus points of Congress and the White House today, which is reshore raw material supply chains and reshore clean, green manufacturing in America.
And surely the army is getting a bit jealous. I don't want to be too facetious, but presumably you've got a conversation going with the army as well. So if you can get the holy trinity of all three defense departments, that would be a real coup, wouldn't it, for the company?
Yeah, absolutely. So look, the Army does use titanium metal as well. So the Navy has got big budgets for building ships and building submarines. The Air Force has got big budgets for building, airplanes and missiles and stuff like that. The Army has got a bigger budget probably around portable weapon systems, things like that. But there is money in artillery, there is money in new, the optionally manned fighting vehicle, they call it, which is a replacement for the Bradley. Titanium is lightweight, it's strong, it's definitely, wins wars. The M777 howitzer, which is, had together with the HIMARS missiles, is a big thing in the Ukraine situation today, in the Ukraine war today. The M777 is a lightweight howitzer, so you can pick it up with a helicopter. It's all made out of titanium. And there has been talk about restarting the manufacturing of those artillery pieces. All that titanium used to actually come from Russia. So Russia into the UK to make cast parts and then come to America to be assembled. I don't think Russia's probably going to allow us to make artillery that's going to shoot against them. So you need to look for other places to make that titanium metal, and we can make it pretty easily.
Yeah. And to demilitarize the conversation, are you talking to golf club manufacturers and hip specialists and medical parts?
I actually had that question on golf clubs and stuff by one of my board members, and I was like, you know what? We haven't actually talked to that side of sporting goods. Look, definitely, we see the DoD intersect as being very, very important from a national security perspective, but quite frankly, we see our commercial success being centered around non-military applications. So you're talking about everything from luxury goods, smartwatches, to bikes, cars, stuff like that. So we have been working with OEMs across different supply chains. For instance, with Carver Pump, it straddles both supply chains. You use titanium metal in pumps for the US Navy. If we make a sustainable titanium pump that's also cheaper, because we can make titanium metal cheaper, we can introduce it more into the chemical industries where they want to use titanium pumps. So absolutely.
Yeah. Oil and gas, desalination, chemical industries.
Desalination, hydrogen generation uses a lot of titanium metal. So we are talking to all these OEMs. I get really excited around wearables and stuff like that, like whether it's watches, smartwatches, things like that. That's really exciting. Very big markets where wherever the consumer wants to see a sustainable product, we are a sustainable product, and titanium has always been considered by the consumer to be a premium product as well. So that bikes, automotive, that's where we have a lot of interaction today. Golf clubs eventually. I don't know why we haven't gone and talked to a golf club manufacturer, but I think we announced 40 or 50 NDAs with OEMs in the non-military sector, and there's a lot going on there. I actually have a few calls today with some major OEMs. So it's progressing really well, and this next quarter you're going to see us make a lot of progress on that front.
So really, let's look forward to 2023. It's about the pilot plant, but also those ongoing commercial relationships.
Absolutely, yeah. So the industrial pilot facility is in a really, really good spot. We've just finished some upgrades and commissioning some new equipment there. So we're really able to produce a lot of titanium metal powder today, and we have our own 3D printing capacity as well. So we have our own 3D printers. So sometimes we work with customers where we can ahead of signing an agreement and being able to press release something, we are printing prototype parts for different customers. So we're able to take our powder from scrap, produce these prototype parts all in our pilot facility, and we have the capability to do a lot of that for prototyping. So we expect that to lead to a lot more of these OEM relationships, these announcements, in the coming months. But then we're focused on those relationships, announcing those relationships, and then scaling up our production. So we announced late last year, or September last year, that we're moving into a building in Virginia, which was, we had Governor Youngkin come and present me with the flag of Virginia, of the Commonwealth. We're upfitting that plant as we speak. We've been securing the long lead time items over the last 6 months, and we expect to be operational in that plant at the end of this year. So that will take our capacity to about 125 metric tons per annum of titanium metal powders. So a significant amount in today's world. And then from there, we are doing detailed engineering design right now and down to stamped drawings for electrical work, piping work, all that for the 125 metric tons per annum. But we're also doing some engineering work around how big we could take that facility. So could we get to 1,000 tons or more in that current facility? And then what does our scale up from there look like? So in the next few months, I would like to update the market on how that build out, we call it the titanium demonstration facility, how that build out is happening. And then our scale up from there over, say, the next 5 years, how we're going to get to 1,000 plus metric tons per annum, which really gets you into being the largest metal powder supply in the world.
Sorry, did you say 1,000 tons plus?
That's what we're looking at. How do we get above 1,000 metric? Can we get to 1,000 or above 1,000 metric tons per annum? So there's more to say there. But right now it's at 125 metric tons per annum is our detailed engineering design, and we're doing some of that preliminary engineering design of, can we get to those sort of levels in the current facility.
And you talk about a $20 million cost, $8 million of which is CapEx, potential funding of $4.5 million. What's the other $12 million associated with, and can you just kind of describe the broader funding package?
So there's a lot of contingency in that. There's quite a bit of contingency in that. So we put a big contingency factor on the build out, and then you look at, so this is a shell building right now. So we're building out office, laboratory, additive manufacturing space, and then you got quite a bit of work. A few million that goes into HVAC, piping, electrical. So we're going to have some updated numbers to the market in the coming months, and that will really lay out pretty much everything will be quoted, or close to everything will be quoted, and then we'll be able to lay out also that expansion. So it's relative to, say, what you see in mining, it's quite cheap. The bang for your buck is really, really good. And this will display the technological maturity of our process as well. So it's going to be the only plant of its kind, and it's going to really take us into being a commercial producer of titanium metal powder.
And what's your balance sheet like at the moment? Where are you?
11 million US was in the last quarter. So that's not including what we get from the Air Force Research Challenge. We actually did have revenues November, December last year from Panerai. So we will continue to be producing product for Richemont and the group there. And then with some of our prototyping, we do get paid for. So small revenues, but we expect once the TDF is operational for that really to scale up. A lot of the equipment we're buying is off-the-shelf equipment, so we are looking at opportunities to lease a lot of that equipment. There's regional banks who are interested in leasing of that equipment to us. So we're in quite a good position, and like I talked about before, there's a lot of government programs out there which we are in the running for, which want to support scale up of either green manufacturing stories, sustainable manufacturing stories, or these sort of raw material supply chains that are in dire need to be reshored in America. So we feel that we're in a very strong position today with our balance sheet.
The board level, conversations at the boardroom, that they're not, well, maybe we should do a kind of a buffer raise, kind of taking 10 or 15 or 20, just to give you kind of more headroom. How does that conversation go?
Nothing at the moment. The board level discussions are really around our OEM discussions, because we're in discussions with some major OEMs right now, and that takes a lot of the board discussion at the moment. So we see signing more customers as one of the key focal points for our company today. And then completing all the engineering design and getting everything quoted is a key focal point as well. That will be complete in the coming months before we even look at, what buffer do we want? What, do we approach anything from the financing side? I think that's for us, that's the most important part. Is over the next 6 months, we're going to look to sign more customers, complete all the detailed engineering design and the engineering design and the preliminary designs for what we scale to, and sort of communicate that to the market, which I think will be a very, very positive, could give us a lot of positive momentum. The other thing that we haven't talked about is on the Titan project, we are actively looking at permitting of that. We are taking the view that we would like to have this project permitted this year. So we are in the process at the moment, and there could be some positive moves on that in the coming months as well. So we're focused very much on that before we think about any financings.
So effectively what you're saying, or the implicit in those statements, is that you view these as potential value catalysts or milestones to get the company viewed in a different light by the market. So you're hoping for a re-rate opportunity on more commercial contracts, an indication on the cost and the scope of taking your pilot plant from current levels to 125 tonnes per annum, potentially up to with a pathway up to 1,000 tonnes per annum, and de-risking the timeline on Titan by getting those permits in place.
Absolutely, yeah. All that should be commercial validation, should give us a re-rate. In addition to that, though, Merlin, we also, we are deep in with some of these government programs which are grant opportunities. So the company I was founder of before, IperionX, received $141 million from the Department of Energy late last year. So there is a lot of money in the Defence Production Act specifically pointed out for titanium, both for mineral production, but also especially for metals production. So there's we should make sure that, before we even think about financing, we see where we are at on some of those programs that we have applied to. We've applied to a range of programs. And we feel very confident on a few of them. So it could be a point where a lot of our growth is funded because of the government putting funding towards these sort of supply chains.
Good. Yes. Absolutely. You must pursue non-dilutive financing if the opportunity is there. On Titan, you produced a scoping study last year, and the traditional route is scoping study, then pre-feasibility, and then feasibility. And there's a staged de-risking period in the life cycle of an asset. And I know you said you're going for the permitting for the overall project, but where are you in that pre-feasibility study, feasibility study trajectory?
Yeah, it's a good question. So typically as you would know, like a lot that goes into pre-feas and feasibility is dependent on metallurgical test work. So that's typically your long lead time item in any of your engineering studies, because we're not talking about a project which needs to build any infrastructure. Actually, we're just building the mine site and processing infrastructure. So this is a very straightforward project. There's nothing complex about it. It's off the shelf, heavy mineral sands with a high amount of titanium, zircon, and rare earth minerals in it. good grade, great assemblage, fantastic location being in the middle of the US. So it's a pretty straightforward project. Now, for us, we looked at that feasibility level metallurgical test work as the linchpin in what will drive our timing to get pre-feasibility and feasibility complete. So we decided to complete that. So we took a 13-ton bulk sample and a range of 1-ton variability samples from around our Titan project. Those were run last year. They're complete. Now we're assembling and putting together the final report. So we are in a good position to have hopefully this quarter we can announce that the feasibility level metallurgical test work program is all complete, even ahead of us even completing the pre-feasibility level studies. So that's a big long lead time item. That's a tick in the box. But then for us last year, we took a bit of time to step back and say, we have the scoping study. What do we need to do from now to maybe de-risk that scale up, that scoping? Because at the scoping study, we went straight out for a large project, about a $230 million build. How did we build that in phases? But even more importantly, especially here in the US, where you've seen most companies get tripped up on permitting, how do we accelerate that permitting and try and remove that risk factor from the market? So we've really focused more on permitting and that long lead time item of feasibility level metallurgical test work, because we'll have the test work complete. Well, we have the test work complete. We'll make the announcement once we have the reports and it's all analysed back. But then we'll also hopefully have our permits completed. And then the progression through pre-fees and fees, we will do that. It's just pretty straightforward. I think today a lot of people, even if we go through pre-fees and fees, they'll still be asking, well, where's the permits? Because a lot of the projects in the United States today are held up on permits. So we want to show that we want to take that risk away, so that when we do progress through pre-fees and fees, we can progress rapidly through those, because this is a very simple project. And the market can feel confident in that we're not progressing through these and then they're going to get caught up on permitting. So we decided to spend our capital and our time on really nailing that down. So a lot of time with the community and a lot of time on that.
On that permitting, is that just to make sure that your activity levels stay within the state level of permitting rather than going up to the federal level? Is that the key threshold?
Yeah, so you wanted, in the United States, like actually a lot of other countries, I saw this in Canada with my first company, if you interact with any waterways, wetlands, anything like that, you get into a very detailed, very long permitting process. So in Canada, if you're on lakes or anything like that, you're going to be in a 5-year plus permitting process. I mean, you're just going to have to be. In America, if you get into wetlands, you may never get it permitted. Like what you see in some of these nickel projects, where they are impacting some of these wetlands. Where we are, we don't impact any wetlands, don't impact any streams. So we're lucky in that we stay away from that sort of federal side, but you still don't want to take it lightly. We did all our hydrogeological surveys, we did our cultural surveys, all our endangered species surveys. We took over a couple of years doing that. As from when we started the Titan project, we started all that work, knowing what we need to do. And then really it was around the permit applications and making sure that we had good interaction with the state government around exactly what they wanted from us. And then we had a lot of interaction with the community, and we continue to have a lot of interaction with the community. So we feel we've got good support there, and now we're at that point of where we're actively permitting the project.
Good. I mean, a pre-feasibility study is traditionally the time when you do all of the option studies, the trade-off studies. You look at the right scale, what maximizes your NPV on a throughput and an output rate. But actually, the thing that really changes your NPV is your time to production. So if you can do anything to bring your production timelines closer, even if it's, let's say, on a theoretical basis, is not the maximum NPV on a output rate, but if you can actually shorten that permitting timeline or that time to first production, then you'll probably end up with a higher NPV than a different output rate.
Yeah, absolutely. So, you here in these heavy mineral sands projects, we're pretty consistent. Geologically, it's very consistent. It's not like it's not even like a pegmatite. It's not like a lithium pegmatite, body of lithium pegmatites, where you definitely want to be here because you're thicker, lower strip ratio, whereas, you can't be there. Really, anywhere on our property is pretty much going to be the same, plus minus a little bit. You're not going to see a huge change in NPV. We had already run a lot of this internally as to where we should start. Um, so it's more like a coal project where it's just a consistent layer of sand with a lot of these critical minerals in it. So we narrowed down very quickly. Now we have a lot of in these state permits. You have flexibility in within your permit boundaries of where you start and what you do. You may have to do a small amendment, but it's not a huge thing once you've gone through all your public comments and all that sort of stuff. So, we are in a really good position to be able to have flex, still some flexibility in that pre-feasibility study when we go through it. But we sort of know where we want to be. We want to bring that capital down. We want to start in a phased approach. We then want to phase up. But you're right. If we get this, you get this into operation, and you're theoretically able to bring that and show to the market that you can start this project in a few years' time. That's great for us. We believe if we can be permitted this year, there's a good chance that we can at least start some dirt moving for setting up, processing facilities and stuff like that later this year as well. So you can start ordering long lead time items. This is a very straightforward project. There's not a lot of, from what we've seen from our metallurgical test work program and everything, it's not lithium pegmatites or anything like that, where it is a bit more complex, or gold.
And do you have a target? Do you have a target date for your pre-feasibility study?
I don't want to give a target date until I know more. Over the next few months, we're gonna know a lot more around our permitting, and then what I will say is that we're ready to press the button on pre-feasibility study as soon as we want to. And I think, given a lot of the work we've done internally, our pre-feasibility study will be quick. I don't want to give the timeline, but it will be very quick. And if we started it in the second quarter this year, we'll definitely get it done this year easily. So we're in a really, really good position to progress into that pre-feas. And then with some things, with some of the long lead time items, we know exactly what we want to use with those long lead time items. So we're in a position also to potentially put orders down later this year for long lead time items while we're completing the rest of our engineering studies. Our people that work for me have actually, it was part of the group that also had built the Luca facilities in Virginia. So we know, and actually both built the Luca facilities and built the last heavy mineral sands operation in North America. So we know what we need to do. The engineering studies is, I wouldn't say fait accompli, but it's just a set of studies that needs to be done. Once you've got your metallurgical test work done, you know what type of spirals you need, what type of electromagnetic equipment you need and stuff like that. So we are pretty well advanced internally on what equipment we need, so we can very quickly advance and start procuring that long lead time item equipment. And if we get lucky and everything's ready to go at the end of this year, and we want to push the button to start the Titan project, we could be operational, very quickly.
Finance a question over that, of course, but let's cross that. Let's cross that bridge when that particular challenge comes front and center. Just to wrap up, thank you. It's been really, really interesting. But if you could just summarize kind of your kind of key newsflow items quarter by quarter, what you're looking to block out to the market. And I know that there are some moving parts as well, but both in terms of Titan and the metal, that'd be great.
Yeah, absolutely. Before I get onto that, what I will say about the Titan project is that one thing about these sort of critical mineral projects is that if you have a permitted, ready to be built project in the United States which produces rare earth minerals, we'll probably be the only one that is able to do that. you have, and titanium as well, you will have a range of groups out there wanting to take, whether it's a joint venture position or what have you, in funding that project. So we see the Titan project for me is most, ideally, in the ideal scenario, it's most likely funded externally by others that want the end product. When I look at the remainder, so this quarter through to fourth quarter next year, this next 2 quarters are big quarters for us. Next 2 quarters is where we hope to sign some of our major commercial partners around titanium metal. And the next 2 quarters are where we want to make some major announcements around scale up our ambitions for our titanium metal project. Then over into second quarter, we want to be in a position where we are making some progress on Titan, but that's still a lot to be seen then. But we feel very confident. And then as we get into third and fourth quarter, it's really starting on the build out and commissioning of our titanium metal facility. And assuming we achieve permits in Titan, it's really starting to look at securing those long lead time items for Titan and some of those potential commercial partners for Titan as well. Really, it's this quarter, next quarter, where I see a lot of value add in what we're doing on the ground.
You're pretty positive about these permits on Titan,
Quietly optimistic. I've got very strong relationships, and my team has very strong relationships with the people on the ground. But we still, anything can happen. But we're very well. We respect the community a lot, and we have for the last 3 years, and we've built I've built good friendships out there with some of the key landowners and key officials out there. So it's we're in a very strong position, and we see that generally we're wanted out there because we have been doing things right. But again, let's see where that gets to.
Great. Well, good luck with it all. Thank you very much for the time today. It's been a fascinating update. I'll hopefully catch up with you on the back of your next big announcement, and you, hopefully that'll be in Q1 or Q2.
Absolutely, Merlin. I look forward to it.
Go well.
Thanks.